This video is about finding the equation of tangent line at a point on the curve and finding the value of k such that the line is tangent to the curve. Let's review. Equation of line in point slope form is y minus y1 equals to m times x minus x1. And equation of line in slope intercept form is y equals to mx plus b. Slope of tangent line is the first derivative of f of x. Example 1. So let's find the slope of the graph of the function at the given point. So let's start with function which is g of t equals to minus 3 sine t plus 5. So differentiate with respect to t. So g of t becomes g prime t, and we can put d over dt and minus 3 sine t plus 5. Now we can apply some rule of differentiation and the constant multiple rule. So we have g prime t equals to minus 3 times d over t of sine of t plus d over t of 5. Now we write the derivative of sine of t, which is cosine t, and the derivative of 5 is 0. So we have g prime t equals to minus 3 cosine t plus 0. So if we simplify, it becomes minus 3 cosine t. Now we substitute t equals to pi over 2. So this becomes g prime pi over 2 equals to minus 3 cosine pi over 2. Now we check cosine pi over 2 either from the table or unit circle. So cosine pi over 2 equal to 0. So this becomes minus 3 times 0 equal to 0. So the slope is 0. Let's find an equation of tangent line. Let's consider this function f of x equal to minus 2x4 plus 5x squared minus 3. And the point on the curve is 1, 0. So let's find the equation of the tangent line to the graph of the function at this given point. So step 1. First find the slope of the tangent line to f of x. So let's start with f of x equal to minus 2x4 plus 5x squared minus 3. So let's differentiate. So this becomes f prime x d over dx of minus 2x4 plus 5x squared minus 3. Now we can apply this sum and difference rules and break it down this derivative into three derivatives: d over dx of negative 2x4 plus d over dx 5x squared minus d over dx of 3. So we can apply the combination rule, which says d over dx of c times x to the n is c times n to the x n minus 1. So we apply this rule on this one, so you have a negative 2 times 4 times x to the 4 minus 1, 3. And then plus 5 times 2 and x the 2 minus 1, which is 1. And the derivative of 3 is constant, and the derivative of constant is 0. So now we simplify it, and you have a first derivative, f prime x is minus 8x cubed plus 10x. So now we need x value and go to the point, and x is 1. So we substitute x equal to 1 in this derivative. So we have, this is the slope. So slope m is f prime evaluated at 1 equals to minus 8, 1 cube plus 10 times 1. If we simplify, so 1 cube is 1, we multiply with negative 8, so we negative 8 plus 10. So a minus 8 plus 10 is 2. So slope is m equals to 2. So step 2. Now we write the equation of tangent line using the slope m equals to 2 and the point 1, 0. So here m is 2, x1 is 1, and y1 is 1. We can use the equation of line, which is point slope form, y minus y1 equals to m times x minus x1. So we substitute x1 is 1, y1 is 0, and m is 2. So we have y minus 0 equal to 2 times x minus 1. We distribute and simplify, so you get y equals to 2x minus 2, which is the equation of tangent line. So determine the points, if any, at which the graph of the function has a horizontal tangent line. So start with the function y equals to x squared minus 2x plus 3. Differentiate with respect to x. So y becomes d over dx equal to d over dx of x4 minus 2x squared plus 3. Now we apply the sum and difference rules. So we have a d over dx, actually 4, minus d over dx 2x squared plus d over dx of 3. Now we apply the power rule here, and so bring the power down 4 and subtract 1. And here we apply the combination rule. So minus 2 times, bring the power down, subtract 1 from the power, and 3 is a constant, and the derivative of constant is 0. So let's simplify this one. So this becomes 4x cubed minus 4x plus 0. Again, if you simplify, it becomes 4x cubed minus 4x. Now we set this denominator to 0. Why? Because this is slope and horizontal line, the slope is 0. So we set the first derivative to 0, and now we can look at this equation 4x cubed minus 4x equals 0. So it looks like we can factor 4x. So we factor 4x, get you x squared minus 1. Now x squared minus 1 can be factored also into x plus 1 and x minus 1. So now divide the 4 both sides. 4 cancels, 0 over 4 is 0. So we have x times x plus 1, x minus 1 equal to 0. Now we set all the factors to 0. So if we set x to 0, you got 1x value, and then x plus 1 equal to 0. You move 1 to the right side, and it gives the x equal to negative 1. And then set x minus 1 to 0, move negative 1 to the right and make it 1. So we have another x value. So now we have found, we have found x values where tangent is horizontal, and these are x equal to negative 1, 0, and 1. Now for each of these x values, we have to find the points. So to find the points where the tangent is horizontal, we substitute x equals 0, x equal to minus 1, x equal to 1 in the original equation of the curve y equal to x4 minus 2x squared plus 3. So let's see, when x equal to 0, then after we substitute 0 in this equation of curve, that becomes 0 to the 4 minus 2 times 0 squared plus 3, which simplifies to 3. So the point where the tangent is horizontal is 0, 3. Now we use the next x value, which is negative 1. Substitute the equation of the curve. This becomes negative 1 to the 4 minus 2 times negative 1 squared plus 3. Fourth power of negative 1 is positive 1. Square of negative 1 is 1. Multiple of negative 2 is negative 2, and plus 3. So now 1 plus 3 is 4. 4 minus 2 is what? 2. So the point is negative 1, 2, where the tangent is horizontal. Now, next value is x equal to 1. We substitute again in the curve, and it becomes 1/4 minus 2 times 1 squared plus 3, and 1 to the power 4 is 1, and square 2 times 1 squared is 2 and plus 3. So 1 minus 2 is negative 1 plus 3, which is 2, so we have a point 1, 2. Now we put these answers and this together, and these are the first point minus 1, 2, second 0, 3, and the 1, 2, and these are the points where the tangent is horizontal to the curve. So example 4, finding value of k. Find k such the line is tangent to the graph of the function. So step 1, first we identify the slope of the tangent line. And the slope of the tangent line is the number multiplied to x, or coefficient of x. so the m is negative 2. Now we find the first derivative of this one, and as you know, the first derivative represents the slope of the tangent. So let's find the first derivative. So write an f of x equal k over x. Now we have to move the x to the top and write in exponential form. And here is the rule: 1 over a equal to a to the minus 1. So this becomes k times x to the minus 1. Now we can differentiate using the power rule. So it will be k times, bring in the power negative 1 and subtract 1 from 1. So k times negative 1 would be negative k, and this will become x to the negative 2. And now again apply this rule, negative exponential rule. So remove this to the bottom, make it k over x squared. So the first derivative is now minus k over x squared. Now as we know, the first derivative represents the slope of the tangent, and the slope of tangent is also given m equals to negative 2. So we'll equate this slope, these slopes. Okay, so we're going to equate this slope m equal to negative 2 and the first derivative negative k over x squared. So we get an equation negative k over x squared equal to negative 2. So now we multiply both sides by x squared. Okay, we have to solve for x. So it becomes x squared times negative k over x squared equal to negative 2 times x squared. Now this x squared cancels with x squared, and negative cancel with negatives. So you have a k and you have a 2x squared. Now we substitute k is equal to 2x squared in the equation of the curve or equation of function f of x equal to k over x. So this becomes f of x equal to 2x squared of x. Now this can be simplified to 2x. Now we take this is the value of y. We take this y equals to 2 and substitute in the equation of tangent line. Y equals to negative 2x plus 4. So we have now equation 2x equal to negative 2x plus 4. So we move the negative 2x to the left side, so we'll get 2x plus 2x, which is 4x, and we divide by 4, and we get x equal to 1. Now we substitute x equal to 1 in equation k equals 2x squared. So we get to k is equal to 2 times 1 squared, which is 2 times 1, which is 2. So the k is 2.